Greetings and welcome, friends. Mr. Waddy here. We've been talking about, I don't know, we're like probably, what, section 8.3 or something? Yeah, I think so. And we were graphing functions, quadratics of the form f of x equals ax squared plus bx plus c. And that little bx term, boy, that's just messing everything up for us, isn't it? That's unfortunate. But I'm going to show you some tricks as to how to deal with that. So I'm just going over the homework here. So this asked us to find the vertex, the axis of symmetry, and the y-intercept of the graph. The vertex for these occurs where the curve changes direction, right? So this one was increasing and now it's decreasing. This one was decreasing and now it's increasing. And so our vertex is going to be an ordered pair. This one's -3, 2, right? And that's the kind of most significant point for our parabolas. This one looks like it's at -1, up 1. Make sure you're checking your scales on your axes, so that way, you know, you're not getting all confused and misinterpreting those, potentially. Let's see, they wanted the axis of symmetry, and the axis of symmetry in Algebra 1, anyway, will always be a vertical line that passes through the vertex, and it's going to be x equals a number. So the axis of symmetry is not a number, it's an equation that represents a line. All right, so x equals -3 is the equation of a vertical line that passes through that vertex, and it's the axis of symmetry because our graph is symmetric or mirrored over this line. All right, over here the axis of symmetry is going to be the equation x equals -1. And you can notice that it's always just going to be x equals whatever the x coordinate of the vertex was, is kind of the quick way to figure that out. Y-intercept is where it crosses the graph. So this y-intercept is over here. And that looks like it's at -1. Here, this y-intercept is at 5. And the y-intercept is technically just the y-coordinate of that point, but it's also not a bad idea to just realize that that is occurring at the point 0, 5, and this is occurring at the point 0, -1. So a y-intercept isn't technically reported out as an ordered pair, but I like to sometimes remind myself of that. And then one of the benefits we had later on, in the next example we'll do, is once I have a y-intercept that is not a vertex, I can actually find another point by mirroring, right? So this is 3 units away from the axis of symmetry, so 3 units away over here, I could find another point that would be -1 high, right? So that would work, or this is 5 units high and is 1 unit away from the axis of symmetry, so 5 units high and 1 unit away from the axis of symmetry over there would be another point. And so those I consider kind of freebie points where you can find those without having to make a table of values or nothing. Okay, here we go. Wow. So one of the things we figured out for the vertex is the point, I started calling it h, k, and the x coordinate of the vertex, h, is able to be found by doing this little formula, -b divided by 2a. All right, -b over 2a. And then I could find k by plugging in h into the function of my equation. So here's f of x, so f of whatever this number is would give me, right, and I'll plug that into all of those x's, will give me the y-coordinate of the vertex. So that's what I'm going to end up doing for these. So the first thing I asked you guys to do was to define your a, b, and c. So a is -6. Write that with an equal sign. Don't just like do an arrow. Right? I've had students do this, and I don't know. Are they referring to 24? Are they referring to x? Are they referring to 24x? But b is equal to 24, and whatever the sign in front of that number is goes with it. So if that was a subtract, it would have been -24, and c is equal to the -20. So to find h, all right, and I'm being a little cautious here with parentheses. It doesn't matter as much for this numerator if the b is positive, but I just want to be careful with a double negative. So negative 24 over negative 12, and then negatives cancel out, and what's 24 divided by 12? 2. Thank you, Brandon. So h is 2. Now to find k, I'm going to do f of 2. All right, I'm taking this number, and I'm just going to plug it into the function. All right, so f of 2 is going to be negative 6 times 2 squared plus 24 times 2 minus 20. And now I've got to PEMDAS this, right? So 2 squared is 4. So negative 6 times 4 is what I'm going to do next. Plus 24 times 2 is 48. You could reach for a calculator for some of these calculations, but only do one operation at a time. I want to see kind of, more of this happening written out. Negative 6 times 4 is negative 24. And negative 24 plus 48 is positive 24. And then minus 20. It looks like I get positive 4 as an outcome for f of 2. Which means that k is equal to 4. And my vertex is going to be 2, 4. Right? So that's I found the vertex already. I did it in the backwards order. Then they also want the axis of symmetry, AOS, is going to be x equals some number, an equation, and what number would that equal? It's going to be x equals a number. This is the equation of the vertical line that passes through the vertex. So x equals 2 is the vertical line that passes through 2 on the x-axis as well as passes through the vertex because it has 2 as its x-coordinate. All right, so this little process, this formula right here was a big deal. Definitely gotta know that guy right there. That's a good one to know. How to find the vertex whenever we have this b term here. All right, and now let's look at this one last example. How am I doing for time? 7 minutes in. All right. Where I'm actually going to take those skills, put them together, and then make a graph. All right. So, let's see. Tyler, could you tell me what do you think A is equal to for this one? What are your thoughts here? How do we find it up here? So down here, yep, right? It's just the number in front. It doesn't include the x or the squared. Let's see. For B, Micaiah, what are you thinking B is? Yeah. And then C, Brandon, -9. -9. And so once again, I'm going to find h by doing negative b over 2a. My a sometimes can look like a 9 there. My apologies. So I'm going to have h is equal to the opposite of -16 over 2 times -8. Careful with all these double negatives here. That's going to be positive 16 divided by, negative 16. And I'm going to get h is equal to -1. So, even with that information, I just want to point out, I technically can figure out the axis of symmetry is x equals -1. All right, so I can, no, I don't have that tool there. Oh, wait, can I? Do I have my cool line tool here? Where's my brush palette at? No, I'm not seeing it showing up somewhere off screen. Oh, well, I was going to use my dotted line tool, but I'll just draw a dotted line instead. Right. So there's my axis of symmetry. And I know my vertex is somewhere on this, but I got to find the y-coordinate of the vertex. And to find that, I know that, k is going to equal f of h. All right, so I'm going to plug in this -1 into my function, and I realize, yeah, this is called y. So, if I called this f of x, that would have worked, but that's fine. I'm basically plugging in -1 for all the x's up here, and I got to figure out what the corresponding y value is. So f of -1 is going to equal -8 times -1 squared minus 16 times -1 minus 9. Hopefully I gave you guys sufficient room on the homework for this, because these problems can take up a little bit of space. -1 all squared is +1, but that -8 is still out front. -16 times -1 is +16 minus 9. So let's see, -8 plus 16 minus 9. -8 and 16 combine to be +8. Ooh, goodness. And I get -1 is f of -1, meaning k is equal to -1. Now, those happen to be the same numbers. That is not always going to be the case, all right? So my vertex is -1, -1. And, oh, careful on my scale. I almost got tricked. What does each tick mark represent here? Yeah. So -1 is occurring here. All right, so careful with that. Don't let that fool you. All right. Let's see. What was the y-intercept? Does anyone know the y-intercept? Yeah. So the y-intercept is whatever the c was. So that's just -9. So -9 is also going to be halfway between our grid. And then I can mirror that over here and get another point. Now, if I wanted more points, this video is getting a little bit long, but I could plug in, say, +1 and figure out where that's going to land, right? And then even mirror that over there. But for sake of time, I'm just going to draw my best parabola based off of roughly 3 points. Something like. All right. So thanks for watching, Internet friends. Have a great day.